Lesson 70, probability in designated order. I have to do all the videos this week. We have to have all videos because we didn't have class. So we'll get all 4 videos. You can watch one a day before you do your lesson. That might actually be helpful. Lots of writing on this page. I'm sorry about that. It's just one of those kind of lessons. Probability. This probability lesson is fairly easy, I think. Probability can get difficult, but we're going to start out nice and slow, so make sure you get it as we go, because as we go through the book, they're going to keep adding more and more things to it. The study of probability is based on the study of outcomes that have an equal chance of occurring. Like if you flip a coin, usually like the probability of flipping a head, you might have heard that, or the probability of spinning a 3 on a spinner, or the probability of pulling a blue marble out of a urn. I don't know why they use urns. They always use urns. Or they might have the probability of getting rolling a 6 on a die. If you've ever heard of that, that's called probability, and that's the probability that something's going to happen. So this is the little formula that we're going to use for all these problems. The probability of a particular event, like the probability of tossing, let me get my pen to work here. Hold on. The probability of tossing a coin and coming out heads. That's what we're talking about. So it would be like the probability of getting a head. So it's out of the number of outcomes that satisfy the requirement. Well, on a coin, how many outcomes would give you a head? There's only one head on the coin, so only the number of outcomes that would satisfy it would be 1. The sample space, the possible outcomes you could get would be you could either get a head or a tail. So it's out of 2. So your probability of getting a head would be 1 out of 2. We're going to get that. I just jumped ahead of myself. Probability of any event is a number between 0 and 1. So if it never can happen, you get a 0. And if it happens 100% of the time, your answer is going to be 100%. Other than that, it's going to be a fraction between 0 and 1. Here's an example. A fair coin, that's a coin, not a point, is tossed 3 times and comes up heads every time. What is the probability that on the next toss it will come up heads? Now they're trying to be really tricky here. They're telling you that it's already come up 3 times heads. So what they want you to try to think is, oh, it's going to be tails next time. But that's not how probability works. These are all independent events. That means if we toss a head the next time, that doesn't matter how many heads. If we toss 99 heads, it still has the same probability of coming up heads the next time. They're independent events. What you do before it doesn't affect what's going to come next. This is the one I just did. I kind of jumped ahead. The probability of getting ahead is the number of outcomes that are head. So there's one outcome that's heads out of the total number of outcomes in the sample space. So total number of outcomes, there's only 2. So coins are the easiest one. 1 out of 2. 1/2. Let's try something a little bit more complicated. 6 green marbles and 8 red marbles are placed in that urn again. So picture your urn, you have 6 green and 8 red. 1 marble is drawn and then dropped back in the urn. The second marble is drawn and dropped back into the urn. Both marbles were red. Here they go. They're trying to trick you again. They're making you think, oh, there's no way it's going to be red again. That's just a trick. If another marble is drawn, what is the probability that it will be red? So here we go. It's the same formula. The number of outcomes that satisfy that requirement. So how many are red? Because they want to know what's the probability of being red. Well, there's 8 red, so the possibility of getting a red marble is 8. Out of how many? Well, there's 6 green and 8 red, so that would be 14. So it would be 8 out of 14, and we're always going to reduce these. So we're going to get 4 out of 7. So your chance of getting a red marble is 4 out of 7. Pretty nifty, huh? I like these. All right, let's move over. Let's do the dice problems can be a little dicier. Oops, didn't make that quite big enough, did I? Okay, a single die is rolled 3 times. One time they rolled it and they got a 1, the next time they got a 4, the next time they got a 3 in that order. Here we go. This is our tricky, they're trying to trick us again. That doesn't matter. It's an independent event. What is the probability that the next roll will produce a number greater than 2? Okay, we're getting really tricky now. So we want the probability of rolling something greater than 2. Well, greater than 2, what numbers? On a die, you have a 1, a 2, a 3, a 4, a 5, and a 6. Greater than 2, there's 4 that are greater than 2. So the possible outcomes are 4. Out of how many? Well, there's 6 numbers on a die. So out of 6. So your answer is, your probability is 2 over 3. Now we're going to get a little bit trickier. 2 dice are rolled. What is the probability if the sum of the numbers rolled is a 7? What is the probability that the 2 are rolled if the number is greater than 8? So we're going to have to think about this one. There's a chart in your book that could help you. Let's just think about these two without using our chart. Number of outcomes that equals 7. So we have to just think of all the outcomes that could possibly equal 7. The little chart in your book, let me see. The little chart in your book could be helpful. I might have wanted to use that, but let's just think about it. The number of outcomes that equals 7. So we could just think these through. We could roll a 1 and a 6, a 2 and a 5, a 3 and a 4. And then you could go the other way. I think that's all the combinations. And then you can do all the other ways. So you could have a 6 and a 1, a 5 and a 2, a 4 and a 3. So there's 6 possible ways that you can roll a 7. Total possible number of rolling 2 dice, where you're going to roll, you could roll 1 and a 1, a 1 and a 2, a 1 and a 3, a 1 and a 4. So there's 36. When you do 2 dice, there's always 36 possibilities. So this is going to reduce out of 1 out of 6 is the possibility of rolling a number that is 7 with 2 dice. Let's look at this chart again. That's so helpful. Okay, let's look at this one. The number of outcomes that are greater than 8. So all the ones greater than 8. You can work this through, but I'm just going to tell you it's 10. You can just come up with these combinations. 10 out of a total possible is 36. And so it's going to be 5 out of 18 are going to be greater than 8, all the combinations. Okay, that's the independent event. Let's look at designated order now. So bear with me while I change my screen. Okay. Like designated order. So this time, we're going to say something, what's the odds of rolling a head and then rolling a tail? Well, the first time you roll, you could get either a head. What? I'm going to change my color again. You could either get a head. Think of the thing as what's the probability of rolling. Probability of rolling a head, then a tail. Okay. So the first time we're going to get a head and then a tail. The next time you roll, you're going to either get a head or a tail. The same with this coin. When you roll, you're going to get either a head or a tail. So the probability of rolling a head then a tail would be 1 and 2 the first time. And then the next time of rolling a tail is 1 and 2. So we have here that you would have the probability of rolling a head times the probability of rolling a tail. And you multiply them together and they get you the probability of rolling a head, then a tail. So this isn't too hard. It says a fair coin is tossed 4 times. What is the probability of the first 2 times it comes up head and the last 2 times it comes up tails? Well, we know with a coin, every time it's going to be 1 out of 2 for getting a head, times 1 out of 2 for getting a head again. The tail is the same. 1 chance out of 2. Getting a tail again is 1 tail out of 2. So the chance of this combination is 1 out of 16. And the last problem is the fifth spinner problem. The spinner shown is spun twice. What is the probability that the spinner stops on 4 and then on 3? So this is the probability of a 4, then a 3. These are independent events. It doesn't matter what happened before it. The probability is going to be the same. So the probability of spinning a 4 is, there's 1 4, and there's 4 possible things it could land on, 1 out of 4, times, when we do the multiple events, we do multiplication. Now we do 3. Well, there's 1 3, and there's 4 possible numbers. So it's going to be 1 out of 16 again. So I don't think these are very hard, but I'm not sure. So give it a try. If you don't get these, just post on the help board and I'll answer your questions. That's it for lesson 70.